So the purpose of this video is to discuss this handout, and the purpose of the handout is to guide you through how to choose the right path to take when you have either two angles in one side or two sides in one angle. And these are all using the law of sines. So if you have all sides, then you use the law of cosines. If you have a side and two sides and the angle between them, you can use the law of cosines. But this is for the law of sines. So what I'm going to do is show you how to work this, and I'll give you an example of each scenario that we're going to look at. So the first thing is, if you're given two angles and a side, and one of these sides has to have the same letter as one of the angles. Now, I say if your drawing has ABC, uses ABC, and they're not such that this happens to relabel them, just because then it's easier to follow the method. So if you are given a side length and a corresponding opposite angle, relabel those both small a for the side and a capital A for the angle. And then the second angle that's given, call that angle B. And then what we'll do is we'll find side B, then we'll find angle C, and then we'll find side C in that order. So what I'm going to do is I'm going to add a page and give you an example of that scenario. So that's the easiest case. So let me, and it doesn't matter whether the angles are acute or obtuse. I think you might do the largest angle first, possibly. And you can actually do this step first if you wanted to, because if you have two angles, you can always find the third angle. Okay, so let's just make up a triangle that shows what we're talking about. So here's my triangle. So let's say this is 100 degrees, and this side, the opposite side, is 12, and then this one is 5. That's two sides and an angle. So let's try it again. Let's say this angle here, so this angle is 100 degrees. Let's see, this one is 40 degrees. So like I said, you could figure angle C already. So let's go ahead and label them. So this is side A and this is angle A, because I'm given both the side and the angle. And we'll call this angle B, the remaining angle. So like I said, you could find angle C here. It's going to be, angle C is going to be equal to 180 minus 100 minus 40, which is 40. Let's change that so it's not exactly the same. Let's pick 35. So let's say this is 35 instead. So if this is 35, 180 minus 100 minus 35 is 45. 45, sorry. Okay, let's just start that whole thing over again. Okay, so let's do an example of this scenario. So we're given two angles and a side, and we have a side length that's opposite one of the angles. So the first thing we could do, or we could either do either one of these, we could find angle C. So let's just do that. Angle C is going to be equal to 180 minus 100 minus 35, because the sum of the angles interior to a triangle are 180. So if you know two of the angles, you can always find the third angle. So that's 45 degrees. Okay, so now we know all of the angles and one side. So, and let's one more thing we need to do is let's label this as side C and this is side B. So we have A is the one where the angle is matched up with the side. This is angle B. This is the second angle we're given. Opposite that is side B. We can calculate angle C, the third angle, and the side opposite that is side C. So to find the length of side B, go over here. B is equal to A times the sine of B divided by the sine of A. Length A is 12. B is 35. A is 100. And you make sure your calculator is in radians. 12 times the sine of 35 divided by the sine of 100. And we get 6.99, so I'm just going to say it's 7.0. That's B, so that's side B. Then you can find side C. It's going to be side A times the sine of angle C over the sine of angle A. So side A again is 12. C was 45 degrees. A is 100 degrees. Plug those in. 12 times sine of 45 divided by the sine of 100. And I get C is 8.6. So this is 8.6. This is 7.0. Okay, and it makes sense because the smallest angle has the smallest length side, the next smaller angle has the next size, and then the largest angle has the largest size. Okay, so that's that case. So those are the easy ones. Now the hard one is when they give you two sides and one angle. And what we're going to do is we're going to relabel them so that the angle and side that match are, we're going to use the letter A, and we'll change the second side to side B. So the first thing that you do is you determine whether it's obtuse or acute. Now if it's acute, you go to the back. So with the case of the obtuse, there's two things that can happen. Is A can be greater than or equal to, or less than or equal to B, and in that case there's no solution. If A is greater than B, then you calculate the angle B associated with side B. So you calculate the sine of angle B and then take the inverse sine. Once you have angles A and B, you can find angle C. Once you have angle C, you can find side C. So that's that one. So let's come up with a triangle that has that scenario. So let's make an obtuse angle. So I'm going to go like this, and obtuse is greater than 90 degrees. So let's call this is the angle. This is angle A. Let's say it's 120 degrees. And we're given side B. Actually, we're given two sides. So we're given side A, which is opposite. So we're given this side over here. So that's going to be side A. And either one of these can be side B, so we're going to call this side B. So let's give you some numbers. This is 120. Let's say that is equal to 5, and B is equal to 7. Now, obviously, this is not to scale. So if I were to draw this to scale, what would happen is this side would be that length. So if this is 7, then this would be about 5. And the reason you don't have any solutions is that the solution has to occur, this thing has to swing around and somehow run into this other side, the flat side here. And if A is less than B, then we never get a triangle happening. So if A is equal to B, then you just have a line here. But if A is greater than B, then you have this scenario. So in that case, you have one solution, because the other solution would be over here if you just swing this thing around. It's only one place this thing intersects this line here, which creates that angle. Okay. So in my original, the way I originally had this, if I didn't have this triangle drawn and I was just given these numbers and I haven't drawn the triangle yet, what I would do is I go in and say, is A less than B? Is the side opposite the angle smaller than the side adjacent to the angle? And the answer would be yes, and therefore there's no solution. So you'd say this can't happen. Now if I flip these around and say this is 5 and this is 7, then I will get a solution. I'll get one solution. And the procedure I take is the one that's over here. So let's do the calculations now. So the first thing it says is, unlike the first problem, we can't calculate angle C because we only know one of the angles at this point. So we need to calculate one of the angles, and we calculate the angle associated with this side, which would be angle B would be over here. This would be side C, and this would be angle C. So it says the sine of angle B, using this formula, is equal to the sine of angle A times B over A. So we do the sine of 120. B is 5. A is 7. Plug those into the calculator. And I get 0.619, the sine of B. So then to find B, you take the inverse sine of 0.619. Which is 38.2 degrees. Okay, so that's angle B. Now, the next thing you do is you can find angle C, that's 180, minus angle A, which is 120, minus angle B, which is 38.2. And this will always work out so that you have something left over. So you have 180 minus 120 minus 38.2, 21.8 degrees. So these are all degrees. So once you've found angle C, then you can find side C. Side C is side A times the sine of angle C divided by the sine of angle A. So we have side A, which I've got to go back up to my drawing here. Side A is 7. So we have 7 times the sine of 21.8 degrees divided by the sine of A, which is 120 degrees. So 7 times the sine of 21.8 divided by the sine of 120 is 3.0. So let's write those in here. So this is 357. This is 120. Angle B was 38.2. The third angle was 21.8. Notice that the side opposite the smallest angle is the shortest. The side opposite the next bigger angle, which is B, is next. And then the side opposite the largest angle is the largest length. So obtuse is not that hard. You either have no solutions because A is less than or equal to B, or you have one solution if A is greater than B. Okay, so let's go to the second page. So this is if the angle given is acute. So you're given two sides and an acute angle. So you look at first, is A greater than or equal to B, or is A less than B? If A is greater than or equal to B, you basically follow the same solution as you did last time, because there are there's one possibility. So there's one solution if you're given an acute angle and A is greater than B. Okay, so let's try an example with that. So I'm going to write some numbers out here. So let's say angle A is acute. So let's say it's 40 degrees. And we'll let A equal 7 and B equal 5. So here A is greater than or equal to B. 7 is greater than or equal to 5. So it follows this left path. Now, again, we could try to draw this thing. So let's have a horizontal side. Here the angle is 40 degrees. The length of the opposite side is A, and A is greater than B. So let's so this is side A. This is angle A. This is side B. So what happens here is if I take this thing and I rotate it around, you can see that there's only one place this thing can run into the extension of this. We don't know this side, so it can go out forever, but it does define one side of this angle. So I could draw that out and I get one solution. Now if I go this way, if I rotate it this way, when it rotates around, it's going to come over here, and there's no place for it to intersect because this side of the triangle has to go from left to right, out this way. It doesn't go the other way. So there's only one way that can happen. Therefore, there's only one solution. So that's why we don't have to worry about it. So let's just follow the procedure here. So the sine of angle B is equal to, going over here, B over A times the sine of A. So it's 5 over 7 times the sine of 40 degrees. Is that right? 47, those go together. Okay. Now because B is less than A in terms of side length, this angle is going to be smaller. So you take 5 divided by 7 times the sine of 40, and you get the sine of B is 0.459. And if you take the B is going to be the inverse sine of 0.459. So I get 27.3 degrees. So that is less than 40 degrees, the original angle. Okay. Next step, find angle C. So C is 180 minus 40 minus 27.3. 180 minus 40 minus 27.3. So I get 112.5 degrees. And then the last step is to figure out the length of side C. It's the length of side A times the sine of C over the sine of A. The length of side A was given up here as 7. Now, because angle C is greater than angle A, this side C should be the longest one. Sine of 112.7 degrees. Keep on the wrong point. 0.7 degrees divided by the sine of 40 degrees. So I get C is equal to 7 times the sine of 112.7 divided by the sine of 40. Don't do it the sine. I almost did it myself. It's a sine of them. Don't divide the 112 by 112.7 by 40. You got to do the sines. And so what I get is 10.0, which is the longest of the lengths. So let's see if we can draw this thing out again. So what you have is you have this horizontal side, which I don't know the length of. We have this side, which creates an angle around 40 degrees. That's about 40 degrees. This length, we'll call that angle A. So length B is this one. So B is equal to 5. So side A is going to be longer. So if it was the same length, it would be like that. It would be a isosceles triangle, but it actually stretched out a little bit like that. And as a consequence, we need to make this side longer to make it all work out. So this is A, which is, this is 7, 5 and 7. This side's longer. So what we found out was that angle B, which is this little guy here, because it's the shortest side, it's going to be 27.3 degrees. Now this one we figured out from the sum of the angles in the triangle. This one was 112.7, and then so that's angle C. This is angle B. This is side C, and then side C was about 10. So that's pretty much the solution. Okay. Now, if A is less than B, then there's 3 situations. Now, to make that decision, you have to calculate the height, which is just B times the sine of angle A. If A is less than H, there are no solutions. If A is equal to H, there's one solution. So you do the same thing as over here. This would be a very specific case. This would be exactly the right length to cause that to happen, but it could happen. And then the other case is A is greater than H. In that case, you'll have 2 solutions. So this is the harder one. So let's do the 2 easy ones. Well, we won't worry about the middle one. That's highly unlikely to happen. If it does happen, you can figure it out. But I'm not going to do that on a test or anything like that. Okay, so what we need is an acute angle given. So it's going to be kind of the same as last time. So you're going to have this horizontal line. You're going to have an acute angle like that. And let's let B equal, let's let B equal 7 in this case. This is 40 degrees. Now, the height is this distance right here. So that's H. So what you can see is if the second side, or the third side here, is less than H, this thing will just swing around and it'll never touch this third side, which is defining the triangle. So that's scenario 1. A is less than H. So let's just pick a number like 5. So let's say A equals 5. And so what you would do is you'd say, okay, well, A is less than B, so calculate H. So H is equal to B times the sine of A. B is 7 times the sine of 40 degrees. So 7 times the sine of 40 is 4.5. Okay, so in this case, A equals 5 h equals 4.5. So this actually does work. This actually is a solution. So let's make a smaller than that. Let's make it 3, because we don't need a to calculate the height. So if a is 3, then in this case, a, which is 3, is less than 4.5, which is h. So a is less than h. So this has no solutions because this thing is not long enough. It just goes, it's like I can't find it. I can run in here, but that's not a triangle. I need to somehow be long enough. Now the second case is where you have a just long enough so that it touches here one time. That gives you one solution at that one particular point. Now the second situation is where a is, say, still less than b, but it's long enough so that it can go either way. It's like a football player and go offense and defense. Okay, and we know what height, the height is 4.5, so I know this is going to work out. So let's say we're given this is our situation. We're given angle A is 40. We're given side A is 6. Side B is 7. So we go to our little spreadsheet here. Is A greater than B? No. Is A less than B? Yes. Okay, calculate H. H is 4.5. So is A greater than H? Is 6 greater than 4.5? Yes. Okay. So that's this third situation. So you'll end up with two solutions. So the two solutions are going to be this one and this one. So you end up with this angle being an acute angle, or this one being an obtuse angle. And they're symmetric around that point. That symmetry is important. We'll use that in a second. Okay, so let's just follow the rules now that we have that scenario. So the first thing is calculate the sine of angle B. Now angle B is this angle, which can be either acute or obtuse. So that's why we've got two paths here, one to find the acute, one to find the obtuse. So you say the sine of B is going to be B over A times the sine of A. So B is 7, A is 6, the sine of 40 degrees. So we get the sine of B is this. Okay, sine of 40 times 7 divided by 6 is 0.74, well, close enough to 0.75. So let's do the left hand first. The left, go this way. So one solution, B is the inverse sine of 0.75. So you get B, this is the acute solution. So we take the inverse sine of the answer, which is 48.6 degrees. Now, the other solution, which I'll put over here, B prime, we don't use the inverse sine because that's still going to give us 48.6 degrees. We need essentially the second quadrant solution. So what we'll do is we'll take 180 minus the answer we just got, 48.6. So the second angle solution, which is our obtuse solution, is 180 minus 48.6, which is 131.4 degrees. So this is one solution, this is the other. Now, in the case here, we same thing. We're going to find angle C by subtracting angle A, which is 40, and angle B, which is 48.6 from 180. So that's a 91.4. That's bothering me a little bit. Because I didn't think that angle could, well, no, I thought that angle had to be no, that's okay. Yeah, we're okay. And you do the same thing over here. 180 minus 40 minus 131.4. So you get 180 minus 40 minus 131.4. It should be a small angle, but it is positive. Okay, so that's angle C. And then finally you find side C, so that you take side A times the sine of angle C divided by the sine of angle A. So we're using the law of sines now. Again, so A was equal to, let's go back up here, A was 6 times the sine of 91.4 degrees divided by the sine of 40. So that's 6 times the sine of 91.4 divided by the sine of 40. So that's 9.3. And over here, side C is equal to angle A times the sine. Now let's use a prime here, so it's C prime. As far as lengths and angles, so this is an angle C prime. A is the same for both of them, so we don't have to do that. So then you do angle C prime divided by the sine of A. So C prime is 6 times the sine of 8.6 degrees divided by the sine of 40 degrees. And so C prime is 1.4. Okay, so let's just look at that scenario here. And what I'm going to do is I'm going to take this and just move it over here so we can look at these two solutions down at the bottom. Okay. Now I don't have these to scale, but what it's saying is that the first solution, this one right here, the one on the left-hand side, this angle is about 90 something degrees. So I've got close to a right angle at that point. And what I'm going to do is I'm going to take this and I'm going to clone it or copy it and put it down here so we can show you both of these scenarios. So this would be angle B, which we're saying angle B is 48.6, and angle C up here is 91.4, and side C here is 9.3. So again, looking in the order of sides, this is the smallest angle, shortest side, next smallest angle, next shortest side, largest angle, largest side. So that's what that one solution would look like. Now down here what happens is this thing comes all the way over to something like that. So let me just move this way. So that's the other solution. So this, I'll just write it, this is 40 degrees. This was angle C up here, this is angle C. So angle C is 8.6 degrees, that little angle here. This is angle B, is 131.4, which makes sense, it's an obtuse angle. This length is 7, this length is 6, and then this side C is 1.4, and you can see this is much smaller than the other two. So all of the parts make sense. So that was this scenario. So it's a little, I think it's a little more straightforward. So I would suggest you just go back and look at it. Look at the examples I did again. So here we have the first one. is where you're given two angles on one side where one of the side matches one of the angles. And then you just follow. You can either calculate angle C, knowing the other two angles, and then find side B and side C. If you have two angles and one side where you have the side and the angle matched up again, if it's obtuse, there's two solutions depending upon the magnitude of A and B relative to each other. But if it's an obtuse angle that's given to you, it depends upon whether A is greater than or equal to B. If it is, that's straightforward. You have to, in this case, you have to calculate the angle first, and then the third angle, and then the third side. Over here, if A is less than B, you need to calculate the height and compare that height with A. And there are three scenarios. If you get A equal to H, then use the same procedure as over here. If you get A greater than H, that's the one that gives you two solutions, one that's an acute solution and one that is the symmetric obtuse solution.